Alright, so we already talked about the relationship between linear scale factor and area scale factor. And now we're going to apply this relationship to an example. In this example, Maggie has scanned an 8-inch by 10-inch photograph to her computer. Maggie would like to increase the area, increase the size, that is the area, by 44%. As she is increasing the area, that means that we have the original 100%, that is the total original area, plus 44%, to give us a total of 144% increase. So this increase is actually our area scale factor. This is equivalent to 1.44 as a decimal. Now, because we found out earlier that the area scale factor and the linear scale factor are related, such that the area scale factor is merely the square of the linear scale factor, to go from area to linear, what we are going to do is we're going to take this area scale factor and square root it. And when we do that, we end up with a linear scale factor of 1.2. So, again, remember that these are going to be different numbers. They're different numbers because you're looking at two different ways of enlarging. Your area scale factor is talking about a change in the areas, and your linear scale factor is talking about a change in the linear dimensions of your photograph or your drawing. And our relationship is still area scale factor is equal to the square of the linear scale factor. Don't forget your brackets. Okay, now that we have the linear scale factor, we're going to determine the dimensions of the enlarged photograph. So, what we're going to do is we're going to take our original dimensions, okay, and convert them with the linear scale factor. So we're going to take here 8, multiply it by 1.2 to get your new dimensions, 9.6 inches. And again, with 10, multiply it by 1.2 to get your new dimensions.
Morning.
Okay, so new dimensions are 9.6 inches by 12 inches. Next, the enlarged photograph will be printed at a digital print shop on a color printer. Assuming the white areas of the photograph will also use ink, that is, all of the photograph requires ink, we're going to calculate the area of the printer that the printer must cover by the following two methods. So we are going to calculate the new area, okay, that area that was enlarged. So one way is to use the new dimensions, which is 9.6 by 12. And when we multiply this, we end up with 115.2 inches squared. The other method of doing that is to take the original area and, using the area scale factor, determine the area of your enlarged photograph. So our original area was 8 by 10 inches, which means 80 inches squared. Taking that original area and multiplying it by our area scale factor. So 80 inches squared multiplied by 1.44. And if we do that, we end with, again, 115.2 inches squared. We are now going to perform a reduction using similar methods. So now she's producing a print whose area will be reduced by 25%. Reduced by 25% means that we are taking the original 100% and subtracting 25% to have 75% for our scale factor for area. Okay? So that means area scale factor is equal to 75% or 0.75. Okay. We're going to take this scale factor and convert it to a linear scale factor so that we can determine the dimensions. Okay, so square root of 0.75 is equal to 0.866. We're going to take this new scale factor. This is now our linear scale factor. And we're going to multiply it to each of the dimensions of the original print. So those dimensions again were 8 by 10. So multiply 8 by 0.866 to get 6.93 inches. And do the same for the other dimension. 10 times 0.866 to get 8.66 inches. So our dimensions are 6.93 by 8.66. That's all. Thanks.